Hey, good morning, everyone. My name's Shaun. I'm from CSIRO, which is Australia's National Science Agency. And we're trialling a practical new eye test for early detection of Alzheimer's disease. And it may also be able to provide a higher resolution and more repeatable monitoring tool for Alzheimer's disease in clinical trials to help in the development of new treatments. The test itself is non-invasive and very simple to perform. And it identifies beta-amyloid plaques, the hallmark of Alzheimer's disease, in the retina at the back of the eye. The trial's a collaboration between CSIRO and Californian-based company Neurovision, who've developed the imaging technology, and also Cedars-Sinai, Edith Cowan University, and McCusker Alzheimer's Research Foundation. I've got nothing to personally disclose. The study's funded by Janssen Research and Development, with partial funding also from Neurovision. So, we know in Alzheimer's disease, we currently diagnose the disease quite late in the disease process. We see brains that have already lost half of their cells in key memory areas, and also brains that are filled with beta-amyloid plaques, the main hallmark of the disease. We know from research, though, that these plaques start being laid down about 30 years before diagnosis is currently made. So that's a huge window of time. And if we had a practical test to pick up these early signs, in future we could be able to administer treatments earlier and give them the best chance to be successful. So that's why we're looking for an eye test to do that. We have evidence from our collaborators at Cedars-Sinai, the Maya Coronio lab, that plaques aren't restricted to the brain in Alzheimer's disease, where they're quite difficult to detect inside the skull, but also extend to the retina, which is a developmental outgrowth of the brain and which is much more easy to photograph. We can see through the transparent layers of the eye. So Neurovision have developed a specialised camera for imaging the plaques. And during the study, participants take a proprietary supplement containing curcumin to highlight the plaques, and they take this in the form of a drink. Now, curcumin is the main component of the Indian spice turmeric, which you'll find in most curries. But it has a couple of important properties for Alzheimer's detection. Firstly, it makes its way to the retina and it binds to plaques. It attaches itself to these plaques. And once there, it can generate an intense fluorescent signal that enables the camera to be able to detect the plaques. And you'll see those as the white spots in those retinal pictures up there. And so far, whenever we look at the eye of a person who has a brain which has high levels of plaque in it, we always see these spots in the retina. These are our preliminary results so far. First 40 participants and the average age of 73 years. There's a comparison of the amount of plaque in the retina on the vertical axis there with the amount of plaque in the brain on the horizontal. And you can see the strong correlation there. So we're seeing the more plaque we have in the brain, the more plaque we see in the retina. Couple of important points there. Every single person who tested positive to high amounts of plaque in the brain tested positive to the retinal test as well. So we had 100% sensitivity and no false negatives. And that's a crucial component of a screening test for Alzheimer's, because we really don't want to be leaving anyone behind when it comes to the early signs. Another point is that in the top right section, you can see a number of Alzheimer's disease participants labelled in red, but also there's a whole lot of healthy controls up there too who are testing positive to both tests. So these are people who are cognitively normal at this stage, but whose brain scans tell us they're on the way to Alzheimer's disease, and the retinal test is telling us the same thing. And this means that the deposition of plaque in the retina appears to be occurring quite early in the disease process before the cognitive decline that leads to a diagnosis of Alzheimer's or mild cognitive impairment. So promising results there, early stages, but promising results in terms of early detection of Alzheimer's. In addition to that, the test could play an important role in monitoring of plaques over time, as they increase due to disease progression or as they perhaps decrease due to response to treatment. A major advantage the technology has is that you can see very fine detail, so 100 to 1,000 times finer detail than brain PET scans. And you can see here some pictures showing a comparison between our images in the live human eye compared to some microscope work there looking at an individual plaque from a post-mortem retina. And we're starting to see similar structure and morphology there, and we're getting down to that kind of fine detail, which means that we can see, we hope we can see, very fine changes over time and be able to monitor much more accurately how well these drugs are performing. Additionally, we can perform these tests, the retinal imaging, a lot more frequently, every 2 or 3 months as easily possible. We can't do that with PET scans, which need to be separated out by about 12 months. So what this means for clinical trials at this stage is that in future, hopefully, the retinal technology could do 2 things. Firstly, it could provide a cost-effective way of developing a balanced cohort, so working out who's plaque positive and who's plaque negative in a much more cost-effective way than PET could do. And then once the trials are running, as a more efficient way of determining how well the drugs are working in a shorter time frame, hopefully leading to an acceleration in the development of treatments. We've started to do some longitudinal case studies already. So this is an individual that went through the retinal imaging in November last year and then again in February this year. You can see some new bright spots, some plaques appearing around this blood vessel, and overall we saw a 3% increase in the number of plaques over that 3-month period. And we'd like to be able to compare this to what was happening in the brain, but we can't do PET scans that close apart. But we do know this individual was mildly cognitively impaired and tested positive to brain plaque burden, so the kind of participant we expect to be on an increasing trajectory in terms of the amount of plaque in the brain. So encouraging signs there in terms of being able to detect small changes over short time frames. That's not been possible in clinical trials at this stage. So just in conclusion, as I mentioned, it's early stages. These are preliminary results. The full study is on 200 participants from the ABLE study in Australia, and we've just done 40 at this stage, but we're already seeing a strong correlation between what's happening in the brain and what's happening in the retina in terms of plaque deposition. We hope this will empower and accelerate the search for better treatments through the advantages I've mentioned for clinical trials. And one day, we hope there's going to be better treatments available, and this can provide, hopefully, a frontline screening tool to detect everyone in the early stages before the cognitive decline and hopefully change the course of Alzheimer's disease.